Now that I gave you an introduction to Kubernetes, let me just talk a little bit about containers in general. If you already are familiar with containers, you can just skip this lecture and continue with the next one. So let's first talk a little bit about the difference between a virtual machine and a container. On the left here, you see what a virtual machine is. You have a server, the physical machine, then on that physical machine you put a host OS, here in green. Then you have the hypervisor, which is going to manage the guest OS operating systems for you. So you can have multiple guest operating systems on one host operating system using this hypervisor. Every guest operation is completely isolated. It has its own binaries, its own libraries. It can run applications. It is pretty heavy. Like a full virtual machine is a full operating system with the binaries, the libraries, and the application bundled. And it also takes some time to boot up. It needs to go through the whole boot cycle, which can take minutes before your guest operating system is live. So that brings us to containers. So here on the right, you see what a container is. You have still the physical server, then you have a host operating system, and then you can have multiple containers on your host operating system using the Docker engine. Docker is just one example of software that is available. There is other software available for containers as well. Here we have 3 containers. The containers contain binaries and libraries with applications in them. They don't need to boot up the full guest operating system. So when you launch a container, instead of waiting minutes, it will almost instantly start your container. So it's a lot more lightweight than the virtual machines. Containers can also be a couple of megabytes, where virtual machines are often a lot bigger. Then containers on cloud providers are still a little bit different than just running a container on a host operating system, because cloud providers still use this hypervisor to isolate the customers from each other. So you still have a server, a host operating system, hypervisor, then you have a guest operating system, and on top of that you have containers. Currently that's just how it is, but you will still get all the benefits of containerization even on cloud. You just have this extra abstraction layer between your containers and the host operating system. On cloud providers, you're typically also going to have multiple guest operating systems running then multiple containers, and those nodes together will then form your cluster where you're going to run containers on. Docker is the most popular container software. There are alternatives available. An alternative to Docker is Rocket, which also works with Kubernetes. If you don't want to use Docker, you can use Rocket instead. Docker consists of Docker Engine. It's a Docker runtime. It's a software to make run the Docker images. And also the software that you will use to build those Docker images to then run on your Kubernetes cluster. You also have Docker Hub, which is an online service to store and fetch Docker images. So once you build an image with Docker Engine, you can then store it on the internet using Docker Hub. You have public repositories and you have private repositories where you can store your Docker images. Docker Hub also allows you to build those Docker images online. So they provide a service to you that you don't have to build them on your PC. You can also build them online. The cloud providers itself also have alternatives to Docker Hub. For instance, AWS has its own repository where you can save your Docker images. You can also run your own Docker Hub. You could run your own repository if you would like to. So what are the benefits of Docker? You have isolation. You ship a binary with all the dependencies. No more, it works on my machine, but not in production. It's the same binary that you use on your machine to test your software that you will be then using in production. So there is a closer parity between dev, QA, and production environments because you are using the same binary. Docker makes development teams able to ship faster. We can build images pretty quick. You can then distribute them pretty easily using Docker Hub or another registry, and then your servers can start pulling those images. This would be a lot more cumbersome with virtual machine images than with container images. You can run the same Docker image unchanged on laptops, data center VMs, and cloud providers. So you can have the same image that you run on-premise and in the cloud, and it should act exactly the same. Docker uses Linux containers, which is a kernel feature for operating system level isolation. The reason why containers cannot go to the host system or to other containers, or you don't see information of other containers, is because of this isolation done on a kernel level. If you have read already something about containers, you probably have seen this analogy already. It's a ship with containers on. So basically with containerization, you just build your container, and in that exactly same state, you can run it wherever you want. The container contains all the dependencies, so it should execute exactly the same, whether you run it locally, in the cloud, on Kubernetes, or anywhere you want to run it. And that is the main advantage of using containers.